So at the beginning of class today, we did a poll on the opinions of students of the exam. And the options were delightful, gruesome, trivial, rigorous, and hateful. And 50% of respondents, that is 16 individuals, said that the exam was rigorous. That was the plurality response, followed by gruesome with 31%, hateful with 13%, and delightful and trivial tied for 3% with one respondent each. So from this, I take that most people felt the exam was challenging. It was either gruesome or rigorous. But the majority felt that it was at least somewhat if not fair is not the right word, but it may have been challenging in a way that was not gruesome or hateful. But if you add together the gruesome and hateful responses, then there are almost as many of them together as there are rigorous. And I'm not surprised that only one person said the exam was trivial. I don't think the exam was actually trivial for anyone because nobody got full points. And I would like to think that the exam was delightful, but I'm also doubting that that is the case for most people. The exams are not designed to be delightful, but they are designed to help you show what you learned in the class so far. So hopefully the exam helped you do that. Are there any questions following up about exams or grading? So there will be a final exam, a second midterm really, that will be very similar to this exam. And it will cover the second half of the course. And it should be similar in difficulty, similar in format, so you kind of know what to prepare for. The kinds of material that are in the second half of the course are a little bit different. There's a little bit more variety in terms of topics and discussion of different NLP applications like machine translation, but also technologies like deep learning. Sorry, I just lost my screen here that I was sharing. So it'll be a little bit different, but it will be a similar kind of thing. So are there any questions about that? So the second midterm will be, it's the same as the final exam, except for historical reasons, we started calling it the second midterm because it's not necessarily a comprehensive final. It goes over material only that is covered in this second part of the course, including HMMs and part of speech tagging, because you do a homework. The homework for that is not due until the second part, but it is, so it will be during finals period, or alternatively, we could do it on the last day of class and have it be 90 minutes as opposed to longer. In the recent past, some classes have preferred that because you get it over with and you don't have another final during finals week. So as it gets closer to that time, we'll do a poll and we'll find out what you would like and do things that way. Akansha asks, could we have a sample exam released probably on Gradescope before the scheduled second midterm? No, we can't do that. We just don't have the resources to put together a whole second midterm exam that is in the same format as the actual second midterm. So I'm sorry about that, but there's no way that we can do that. Any other questions? Can we have more time to do the second midterm? No. Well, you will have more time if it's during finals week, but the exam will also be longer. So it's deliberately too long for you to finish. And we have a reason for doing that. Namely, that we don't want you to have time to go to Google and start Googling for answers and reading papers and so on to learn things that you should have learned during the period leading up to the exam. And we find that having a lot of spare time allows you time to collaborate with other students, which actually was a problem during this exam anyway. So we deliberately keep the scheduling tight, but the class, because the class grades are curved, then it doesn't matter that nobody finishes the exam. It's stressful, but it's that way by design. Does that make sense? So today we're going to talk about a subject I find very fun, which is lexical semantics. What does lexical semantics mean? What does it mean for something to be lexical? And what are semantics, or what is semantics? First, lexical. What does this term mean? So if you think about like a lexicon, what is a lexicon? Well, it's a collection of words. And lexical semantics, so yeah, it's a dictionary. It's somewhat more restricted than a dictionary usually, and it's a collection of words with some metadata. And the lexical semantics has something to do with words. It's something of words. Well, what about semantics? What is semantics? You ever have an it's meaning, right? It's meaning. You ever have an argument with somebody and they say, well, you're just debating semantics. Does that happen to anybody here? Well, you actually have authorization now as somebody who has taken this course. Oh, Ethan says that. You have the authorization to punch anyone who says that in the nose. Because if you're debating something that is meaningful, you're debating semantics. You're debating the meaning. It's not something that is trivial. It's the core thing. And semantics plays the same role in NLP, actually. You know, we do all of this stuff, all of these different tasks. We parse sentences, we do morphological analysis, we do classification, you know, but all of this stuff ultimately is of no value unless it's anchored to something in reality, unless it has something to do with meaning. You know, you're always trying to get at semantics, which is the interface, as we'll see in a way, between this computational world and the real world. And this interface takes place at various levels. One of those levels is the lexical level. So lexical semantics is about the meaning of words, about characterizing the meaning of words in ways that we can use them in applications. So far, we've talked about different things like information extraction in the second lecture, morphology, language modeling, classification, syntax and syntactic parsing. And now we're going to talk about something that matters. We're going to talk about something important. We're going to talk about semantics and pragmatics, which are the glue that connects language to the real world. So in a sense, the other things we've talked about are only meaningful once we take semantics into account. Let me shrink that. So we'll talk about different aspects of semantics. We'll talk about lexical semantics, the meaning of words. That's what this lecture is about word embeddings, and about vector semantics, which is a clever way of getting at lexical semantics. We'll talk about that actually a little bit today, then you have a full lecture on it later. This is an important topic. Model theoretic semantics for representing sentences, and semantic parsing and semantic role labeling, also for representing sentences and clauses in terms of model theoretic semantics or in terms of some other kind of semantic model. Today, we're going to look at three ways of looking at word meaning. The first is decompositional. So it's about what the components of meaning in a word are. The idea is that a word is like a molecule, and it has different kinds of atoms that make it up, that you put together to make that molecule in some configuration. And you can predict what that molecule is, what it means, by the meanings of those parts that you're putting together to make it. And so you can understand the meaning of the molecule by taking it apart into atoms, or you can understand the meaning of a word by taking it apart into meaningful components, features. Then there's ontological semantics. And so this approach to lexical semantics looks at how the meanings of words relates to the meanings of other words in an ontology. So you imagine having a large graph of words with different edges connecting them to each other with different kinds of relationships that can exist between them. And so you don't ever say, this word blue means this range in the electromagnetic spectrum. You simply say that blue is what's called a hyponym of color. And it's maybe a hypernym of azure or navy, or and we'll learn what these words mean later. But they're about covering a subset or a superset of the semantic space that word does. So it's all defined in terms of relationships. That's the ontological approach to lexical semantics. And then there's a distributional approach to lexical semantics, which characterizes words in terms of contexts the word is found in relative to other words. Excuse me, I have a fatherly duty to attend to. I apologize for that. Apparently, all of the professional world has become BBC Dad. And we're constantly being interrupted by our children while we're trying to do work at home. So distributional semantics is about characterizing the meanings of words based on the context that a word is found in relative to other words. And we'll see how that works in a minute. So first, let's look at decompositional semantics. Here we're using a kind of notation from linguistics where you have features, attributes, and if the attribute is active, then you have a plus by it. And if it is inactive or doesn't apply, then you have a minus by it. So we can take boy, girl, man, and woman, and we can characterize them in terms of their attributes, in terms of these three attributes, maybe. This is just an example. You know, really there would be more and different attributes, but just to show you how it works. So boy would be plus human minus female minus adult. And thus it would differ in one feature from girl, which would be plus human plus female minus adult, and also from man, which would be plus human minus female plus adult. So the idea is that making up the meaning of a word, there are a bunch of these features. There's some universal inventory of features. And we can decompose any word, any lexical word at least, into these features. So that's decompositional semantics. What advantages would this have? What would be good parts of this approach to meaning? If you could characterize every word in a language like English in this way, what could you then do? No ideas? Okay, so Abby says it's a fairly complete characterization. And yeah, so it's it would have a fairly complete and interpretable characterization of what each of the words meant. And Olivia says that you could embed it in a vector space based on features, and that's also true. So you could talk about similarity between words, um, relative similarity in terms of the similarity between the vectors that you get. You know, basically you could treat each of these pluses and minuses as ones and zeros, and you have a vector, um, and then you can do all of the fun things that you would do with binary vectors. So, so Sophia Lee asks if, sorry, can someone repeat the question? And the question is, what could you do if you had vector representations like this, if you had feature representations like this of every word in a language? And that's what Abby and Olivia responded to. So the second question is, what is bad about this approach? What is bad about this approach? Okay, so you need a lot of features, right? To cover the whole lexicon, you need a whole lot of features. Um, and you'd have some features, some information that was not relevant. Oh, I think the slides are posted now. Or they will be added very soon. Um, yeah, so Zachary says you'd need a lot of features to generalize most words, and Rahul says some information may be unnecessary or redundant. So here's another question. So where would all of these features come from? Who decides what these features are? And it's kind of difficult, actually. So it's easy for things like boy, girl, man, and woman. But what would the features of green be? If you're to break down green into its components in a way that distinguished it from other colors, what would the features be? How do you divide semantic space into features like this? And how do you settle on a final list? You know, people have tried to do this, and they've been successful in certain domains of vocabulary, but never successful for a whole language. How do you figure out what the features are of a particular word in a principled fashion? Um, and how do you link those features to the real world? Not impossible, um, but also not trivial. So for these reasons, decompositional semantics is pretty much the least computationally useful approach to semantics. Although in a task called semantic role labeling, there is a kind of decompositionality that is sometimes used with these semantic roles. And we may get to talk about that a little bit when we get to that part of the course. But in general, for lexical semantics, um, decompositional semantics is not so useful. Um, but it's a useful starting point for talking about some other things. That brings us to ontological approaches to semantics. So in the decompositional approach, then the meanings of words are made up of little components that you stick together into bigger things. And you calculate the meaning of the whole based on the meaning of the parts. So in ontological approaches to semantics, rather than going from the bottom up, you go from the top down in a way. So you say, this word has this relationship to this other word and another relationship to this other word. And so we don't bother to define that word in and of itself. We define it in terms of its relationship to other words in the lexicon, other words in the language. Does that make sense? So here, let's make it more concrete. So a lot of you have probably encountered the words synonym or antonym when you're in school, when you're in grammar school, or when you're studying for standardized tests. I hope everybody knows those terms, synonym and antonym, basic part of English literacy. So synonyms and antonyms are relations between words, but they're not the only relations that you can have between words. Oh no, there are more. They include hyponymy, hypernymy, meronymy, and holonymy. Who has heard of any of these words? Like hyponymy. I should have done a survey on this. Zachary says he has not. Anisha also has not. Having trouble getting out of the poll thing. Serves me right. Oh, there we go. Okay. Oops. Okay. I just want to know who has heard of these terms. So the truth comes out. Some people have heard of hyponymy and hypernymy. Good to know. Everybody has heard of synonymy. Most people have heard of antonymy. Many people, 12% of you have heard of hyponymy and 6% of hypernymy. Well, what does hyponymy mean? You, 4 people who have heard of it. Did you learn what it meant, or did you just hear the term somewhere? So by the end of this lecture, you will know all of these terms. You'll be the master of all of these terms. Um, they will be your pupils. So synonymy is about equivalence. Two things are synonyms if they are equivalent to one another, if they occur in roughly the same context, like small and little. On the other hand, so synonymy is relatively easy to recognize. Antonymy is about opposition, things like small versus large, good versus evil, CMU versus MIT. And hyponymy is about a subset relation. It's what's sometimes called an is-a relation. So a dog is a mammal. Therefore, dog is a hyponym of mammal, or the set of dogs is a hyponym of the set of mammals. Hypernymy is the reverse of that. It's a superset relationship. So mammal is a superset. Mammals are a superset of dogs. And so that's hyponymy and hypernymy. That's not to be confused with meronymy and holonymy. Meronymy is a part of relationship, like the liver is part of the body, or a liver is part of a body. And holonymy is the reverse of that. It's the has-a relationship. So a body has a liver. So this can be a little bit confusing for people because they'll think, oh, well, liver must be a hyponym of body because liver is like a subset of the body. Is this true? Is liver a subset of body? What do you think? If the set of livers, if liver was a hyponym of body, then all livers would be bodies. Livers are not bodies. Livers are part of bodies. Yeah, liver would be a subset of organs because all livers are organs. So the relationship between liver and organ would be one of hyponymy or hypernymy, depending on which way you're going. So liver would be a hyponym of organ. But liver would not be a hyponym of body. Liver would be a meronym of body. Because liver is a part of a body. It's not the case that the set of livers is a subset of the set of bodies. Does that make sense? Are you following me here? So that's the hardest part actually of this whole thing to get. And once you have that and you have hyponym, hypernym separate from meronym, holonym, and you can remember which thing is which, then you've got this down. Which is a good thing to do because it will almost certainly be on a quiz. You know, on the next quiz, you'll almost certainly have a question about this. So it's a good thing to understand. And these are terms that you'll see all the time in the NLP literature. Like if you're reading articles that have to do with lexical semantics in any way, you'll see these terms. So they're good terms to know. So Sophia Lee asks, so word X is a meronym of word Z, if word Y is a hyponym of word Z? And the answer to that is no, not necessarily. Whether two words are meronyms of one, whether a word is a meronym of another word is completely independent of any hyponymy relations between those words, between that word and other words. So they're just different dimensions. So hyponymy is about subset relationships, and meronymy is about part of relationships, and they're completely different things. Does that make sense, Sophia? Okay. So here is a mini ontology. I told you that ontologies are big graphs where the edges are these kinds of relationships, these kinds of relations, and the nodes are words. Or in this case, and generally, they're senses of words. But you might ask, what is a sense of a word? And the answer is basically that different words, words can have more than one meaning. They can do more than one thing semantically. So the classic example is the word bank. So bank can be a verb or it can be a noun. And when it is a noun, then it can mean a few different things. It can mean a financial institution, or it can mean the thing on the side of a stream or a river bank, money bank. So those are different senses of the word bank. And most words, many words at least, can have more than one sense, which means the language is full of ambiguities because you have to figure out what sense is involved when you hear a particular word or when your NLP system encounters a particular word. But it doesn't make sense to usually to do an ontology in terms of the words themselves. You want to talk about the relationships between the senses, the meanings of the words. So so here is a relationship between door and building, or between door and wall and building. What relationship is that? What is the relationship between a door and a wall, or a wall and a building, semantically? So this is meronymy, right? Oops. What about the relationship between a fence and an enclosure? So is this synonymy? So is a fence a part of an enclosure? I could see how this could be confusing. But I would say this is an instance of hyponymy. So a fence is a kind of enclosure. So some kinds of enclosures are fences, some kinds are walls, some kinds are other things, and a fence is a kind of enclosure. And so I would say that fence is a hyponym of enclosure. Now, you could think of it with a different sense of enclosure as the fence being part of the enclosure. It's not generally how I would think of it. But if a fence was part of the enclosure, then this would be an instance of what? Meronymy, right? So what about build versus destroy? This is going to be antonymy. They're antonyms. How about wall versus surround? Wall as a verb. So this means the first verb sense of wall in our ontology, and this is the second verb sense of surround. So these are roughly synonymous, right? To wall something, to surround, wall something in, to surround something. This would be roughly synonymous. So the slide build is not working properly on. So that brings us to the subject of WordNet. WordNet is the best known ontology for lexical semantics. WordNet is basically a big graph of a bunch of words related to one another ontologically in terms of exactly these kinds of relationships that we've talked about. In fact, exactly this set of relations. WordNet is a glorified electronic thesaurus. What's a thesaurus? Who's used a thesaurus before? Thesauri are things that are used by students to make paper sound more pretentious, right? So the purpose of a thesaurus is you come across a word in a paper that you're writing and it sounds too pedestrian, too normal. So you look up a synonym for that word that is that you don't recognize, and you put that word in your paper instead in order that you will sound smart, right? Except that you end up sounding silly because you don't use the word quite in the right context, and your professors and teachers can tell, and they are mildly amused, but also frustrated. So, but thesauri actually do have useful purposes, and one of them is organizing the lexicon ontologically, and that's what WordNet does. So in WordNet, words are grouped, senses of words, I should say, are grouped into what are called synsets, like synonym sets. So each of these bullet points here is a synset. And the stuff in yellow, these are the members of the synset. So one synset for dog includes dog, domestic dog, canis familiaris. It has definition here, just to help you when you're using WordNet to know what the synset is supposed to be. So it's a member of the genus Canis, probably descended from the common wolf, that has been domesticated by man since prehistoric times, occurs in many breeds. And then they have an example: the dog barked all night long. But then you have other senses of dog in different synsets. And what you'll find is that WordNet is quite sexist. in part because English is quite sexist. So you'll note that dog for female, we have a dull, unattractive, unpleasant girl or woman, dog grouped with frump. But for a male dog, you have, well, somebody who's morally reprehensible, but it's a cad, a bounder, a blackguard, a dog, a hound, a heel. But, you know, politics aside and gender issues aside, this is how WordNet works. So you have these synsets, and then they're associated with one another by hyponymy, hypernymy, by hyponymy, meronymy, and synonymy and antonymy relations. And you basically, everything falls on a big hyponymy hierarchy. So fish is the hyponym of aquatic vertebrate, which is a hyponym of vertebrate, which is a hyponym of chordate, hyponym of animal, hyponym of organism, hyponym of living thing, hyponym of whole, hyponym of object, hyponym of entity. So that's according to WordNet. Some of these you might find a little bit not natural or not characteristic of how people actually use language. But that's what the word fish means according to WordNet. It sits in this hierarchy of hyponymy. This such a hierarchy is called a taxonomy. But WordNet is not just a taxonomy because it has these other relations between synsets. So there's a cool thing that you can do with WordNet, which is that you can calculate the information content of words. So some words, it turns out, have more information content than others. And you can show this in terms of language modeling, actually, and in terms of their information theoretic properties. But you can get this also from an ontology like WordNet. So information content is equal to the negative log of words that are equivalent to or hyponyms of C. So this is the information content of C over the number of words in the corpus. And here below, we have the information content of various words calculated from WordNet. What do you see here? Well, entity is very vague. There's not much information content there. It could be anything. It doesn't tell you much about something to say it's an entity. If I go up to you and say, you're such an entity, you don't know whether to be complimented or to be insulted. If you say, I saw an entity, well, you could have seen anything. But if you say, I saw the shore, then it's somewhat more concrete, right? There's somewhat more information content. And if I say I saw the coast, then it's even more informative. And I saw a hill is more informative than natural elevation. I saw natural elevation. So that's one thing you can do with WordNet. There are other things. In fact, many of you will probably use it in your projects to do evil because you're evil people and you want to make life more difficult for your classmates. So you're going to use it to obfuscate questions and answers in ways that either change in a predictable way or do not change the meanings of questions. So WordNet, luckily for the purposes of evil, is easily available with various interfaces. And you can find those here at http://wordnet.princeton.edu related projects. The easiest to use probably is packaged as part of NLTK, or Natural Language Toolkit, for Python. So you can just import it like this, and then call the Synsets method on this WN object, WordNet object. And it will return a list of Synset objects for dog. And then you can manipulate those objects. You can find out what the synonyms or holonyms or hypernyms are of those things, and have all kinds of fun. So this is something that's interesting and useful for a lot of your projects. But there are intrinsic limits to this kind of resource. So it requires many years of manual effort by skilled lexicographers. And in the case of WordNet, there was a problem, which is that some of the lexicographers were not that skilled. So this resulted in a lot of inconsistencies and issues. And the data in an ontology is only as good as the ontologist. It's not driven by data, it's driven by the lexicographer, by the human. So let's look at an approach to lexical semantics that is data-driven and does not rely on lexicographers. And let's start by looking at beef. Let's say you don't know the meaning of beef. Let's say you live in a country where people don't eat beef. I've heard there are such countries. What would you learn about beef by looking at this set of instances of beef in context? It's from a concordancer. A concordance, the Brown corpus, which is the first large-scale corpus of American English. So you have the Brown corpus here. We have all of the instances of beef, and we've sorted them by the word that comes right afterwards. So, and we got up to H. So what do we learn about beef from this result? What could you tell about beef if you did not know that word? So first you can tell it has something to do with cattle because it occurs a bunch of times for cattle or dairy cattle. What else? So it could be maybe a hyponym of cattle, but it seems to be modifying cattle here, right? It comes next to cattle, modifying it, because it seems like beef is a kind of cattle, or beef cattle are a kind of cattle. Um, what else do you see? So it might be a hyponym of meat. How do you know that? That's what Ryan Matab says. How would you tell that? Okay, such as, this such as phrase, which seems to entail that it's kind of meat, a hyponym of meat. Um, what about, yeah, so organ meats such as beef and chicken liver, tongue, and heart. So you can actually learn a lot about what a word means by the context in which it occurs. In fact, how do you know what words mean? Do you know what words mean for the most part because you look them up in a dictionary or glossary? How do you know what words mean? How do you learn what words mean? So Rahul says empiricism. And what do you mean by that? Can you be more specific? So you experience their usage. Well, what about their usage helps you to know what they mean? Is it just hearing them? So, if somebody just goes and says hyponym, 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 you know, would you learn anything about the meaning of hyponym? Right. As Rahul says, in context, their usage in context. We learn the meaning of words primarily by hearing them used in context. And that's the same thing, with this beef example. You can learn a lot about what beef means just by seeing the context in which it occurs. Same thing is true of chicken, by the way. We won't go through this, but um, you can learn a lot about what chicken means and a lot about what beef means just by seeing what words occur around them. Well, we can take what words occur around a word and we can make them into vectors. So let's say we have some cooking text. This is from the Brown corpus. Um, and we take these four words: apricot, pineapple, digital, and information. And every time, and we move a window across the corpus, scanning the corpus. Let's say the window is um, 5 words wide. And every time um, one of these words is in the middle of that window, and one of these words is somewhere else in that window, then you add one to uh, that dimension in the vector. And the vector for, let's say, apricot or pineapple or digital or information. These are what are called co-occurrence vectors. So if we look at these co-occurrence vectors for these hand-picked co-occurrence vectors for apricot, pineapple, digital, and information, what do we learn about the meanings of these words? What do we learn about the relative meanings of these words? So digital and information occur in the same kinds of contexts. As Daniel Wisego says. And as Olivia Dung says, apricot and pineapple are also similar. All of them occur next to large, but there are certain dimensions in this vector where apricot and pineapple have a lot of counts. And there's some dimensions where digital and information have a lot of counts. In this case, it's all ones, but brown corpus is a small corpus. So just from context, just from this brain dead process of scanning a window across a corpus and counting every time that words co-occur, we can come across something that we can build something that gives a useful characterization of the meaning of these words. So you could also do this with syntactic dependencies, and people have experimented with this. And I'm not going to spend a lot of time with this because this doesn't feed directly into what we are doing now, but it is a useful thing to know. I'm going to talk about a problem with these co-occurrence vectors that we saw. Now, what you would do in practice when we actually use these kinds of co-occurrence vectors directly is that you would end up with a big vector if V is the vocabulary, then you would end up with a big matrix that was V times V. And each of those, each of the rows in that matrix would be a vector for a particular word. So you're doing all of the words together, but some of the words are going to occur together a lot of times just because they're very frequent words. Like the English words the and is. They're likely to occur in the same window a lot of times, not because there's any special association between the and is, just because they're frequent. They don't have anything to do with one another other than their frequency. So how do we address this? How do we deal with these naughty words, these naughty high frequency words that interfere with these relationships? The answer, the very simple answer, is point-wise mutual information. Who here has encountered PMI before? Point-wise mutual information. Or just mutual information? Little different. But point-wise mutual information is astoundingly simple. It's just this. So it's the log of the probability of W and F co-occurring over the probability of W times the probability of F. So the joint probability of W and F over the probability of W times the probability of F. Or in practical terms, some constant n, the log some constant n times the count of W co-occurring with F over the count of W times the count of F. So what is the effect of using pointwise mutual information? If instead of the raw counts in our co-occurrence matrix, if we use PMI instead, what is the result? Yeah, so as Ethan says, even if they are both frequent, if they don't occur often together, the numerator will be small. And so they have to occur a lot together to make up for their frequency if they're very frequent. So that ends up dealing with this problem of words occurring together a lot just because they're frequent. But there's a problem here still, and that is, let's see if we have a slide about it. Oh, that we'll talk about this next time, or Alan will talk about this next time with you. But these numbers can be negative, and you have a weird sort of thing where, if PMI is measuring how collocated two words are, how much they like to be together, what does it mean if that number is negative? It's how much they dislike being together. It's not clear what exactly that means. So in practice, we often use positive pointwise mutual information. We just take the max of 0 and the PMI, and that works a little bit better. So here are some words. This is done in a very primitive way. You just have a big corpus. You have cardinality of V times cardinality of V table of co-occurrence statistics. Or in other words, each of your co-occurrence vectors has the same number of dimensions as the vocabulary. And then you use cosine similarity, which we'll talk about again next time, to compute how similar words are to one another. And you list off the words, you start with a word and you list off the words in order of how high their cosine similarities are. This is what you get. So for rum, you get vodka, cognac, brandy, whiskey, liquor, detergent, bleach, actually. Cola, gin, lemonade, cocoa, chocolate, scotch, noodle. Okay, so these are not perfect, but this is pretty good. This is completely unsupervised, no human intervention. It's just this blind algorithm operating on this corpus. And we're getting out this list of words that have clear semantic relationships to one another. And it's really pretty good. So for write, we get these other verbs of speaking, like and language verbs like read, speak, present, receive, call, release, sign, offer, know, accept, decide. For ancient, some of these are a little weird. You get old, modern, traditional, medieval, historic, famous, original, entire, main, Indian. I'm not sure why that one specifically, um, or African or Japanese, but various, single, giant. This may have to do with talking about civilization. So you get ancient civilization, Indian civilization, African civilization, Japanese civilization. Anyway, but pretty good. So for mathematics, you have physics, biology, geology, sociology, anthropology, astronomy, arithmetic, geography, theology, Hebrew, economics, chemistry, scripture, biotechnology. And most of those fit pretty well. But what does mathematics have in common with theology or scripture? Well, the answer is simple. They all bring you closer to God. Anyway, are there any questions before we finish? Because we have a little bit of time. So Olivia asks, what was the actual midterm grading curve? Curve, just curious. Not the midterm grades. So this is done by Alan, and basically it works like this. I'll get to your question in a minute, Ruhul. It works like this. So the raw grades are computed based on the point allocations in the syllabus. So he computes a raw grade, then he plots kind of a histogram of the grades and looks for breaks. So effectively clustering together people so that there is maximal division between clusters. The first cluster gets assigned to be A's, the second cluster B's, the third cluster C's, and anyone below that D's. So the actual curve is like the cutoffs. So the clusters are generally top heavy. So more people get A's than get B's or C's. Uh, but I can't. I would have to pull up the list of who got what grade in order to tell you anything about exactly how many people were in each cluster. So I don't, as far as the cutoffs, I don't know. And we're a little bit reluctant to hand that information out because the computation that Alan does is not exactly the same as what shows up in Gradescope in terms of dropping homeworks and quizzes. So Gradescope doesn't do some things that we tell it to. So the numbers are not quite right. So if we give the cutoffs, then lots of people will be upset and they'll say, well, I'm above this cutoff and I didn't get an A. And so we would have to distribute actually those scores on Canvas, which we have not done. And we, because it's a midterm grade and it doesn't go on your permanent record and it's important only if you're on academic probation or going up for an internship or something, then we don't typically spend a lot of time distributing that information. So Rahul asks about the project meetings with TAs and instructors and when they will be. So we haven't scheduled those yet. Those will most likely be next week. Although hopefully later in the week because I'm going to be traveling in the middle of the week. We will get back to you on that. We'll have information on that by Thursday. Any other questions? Okay, thank you very much for your attention and for your participation. And I will see you not this week, not next week, but actually not at all in November. I'll see you early in December. So take care between that time, now and that time, and I'll be looking forward to seeing you again or seeing your chat messages.